All right, everyone. Today we're going to read Lesson 1 from Chapter 1 in our science book, Science in the Natural World. Our big question for today is, what skills do scientists use? Now you can follow along while I read and mark your text just like I do. And remember, sometimes what I might mark might be a little bit different than what you mark. So no worries if they don't 100% match. I'm going to start by numbering my paragraphs on the page. Let's get started. My Planet Diary, The Wild Chimpanzees of Gombe. The following words are from the writings of Jane Goodall, a scientist who studied wild chimpanzees in Africa for many years. Now, I know right away that I'm going to want to remember who Jane Goodall is, so I'm going to circle her name. I'm going to underline that she was a scientist who studied wild chimpanzees, so I don't forget. Once, as I walked through thick forest in a downpour, I suddenly saw a chimp hunched in front of me. Quickly, I stopped. Then I heard a sound from above. I looked up, and there was a big chimp there, too. When he saw me, he gave a loud, clear, wailing, "Rah!" a spine-chilling call that is used to threaten a dangerous animal. To my right, I saw a large black hand shaking a branch and bright eyes glaring threateningly through the foliage. Then came another savage "rah" sound from behind. I was surrounded. Because Jane stood still, the chimps no longer felt threatened, so they went away. Now there's a couple things I want to remember from this one. I want to remember that the "rah" sound and what it sounded like, it was spine-chilling, and it's used to threaten dangerous animals. That's going to tell me a little bit more about those chimps. And I also want to go back and look at the word foliage later, so I'm going to circle it so I can look it up. Now before we move on to the next page, let's answer our question over here on the side. The question says, what is one advantage and one disadvantage of studying wild animals in their natural habitat? So I'm going to write advantage because I'm going to think of the good things first. So I think one advantage of studying animals in their natural environment is they feel more at home, and I'm going to see them doing things that I might not see them do if they're captive. I'm going to write there, more comfortable. Might act differently if I saw in captivity. So captivity is like at a zoo, not in their natural habitat. Okay, so now I want to think of a disadvantage. So what's the downside or bad part of studying wild animals in their natural habitat? Right, they might be dangerous. So I'm going to put they might be dangerous. Because they're in the wild, right? Okay. All right, let's move on to the next page. Oops. So what skills do scientists use? Jane Goodall trained herself to become a scientist, or a person who does science. Science is a way of learning about the natural world. Science also includes all the knowledge gained by exploring the natural world. Scientists use skills such as observing, inferring, predicting, classifying, evaluating, and making models to study the world. So I'm going to mark this as 1, 2, 3 on this page. And also, let's go back and find the words I want to remember. So I want to remember that a scientist is a person who does science. And I know that science is going to be a big word because it's already highlighted for me. And I want to remember that it's a way of learning about the natural world. And then I want to remember, and I'm going to highlight this one so I don't cross anything out, that these are some of the skills that scientists use. All right, observing. Observing means using one or more of your senses to gather information. It also means using tools, such as a microscope, to help your senses. By observing chimps like the one in Figure 1, Jane Goodall learned what they eat. She also learned what chimps make and even what games they play. Observations can be either quantitative or qualitative. A quantitative observation deals with the numbers or amounts. For example, seeing that you have 11 new emails is a quantitative observation. A qualitative observation deals with descriptions that cannot be expressed in numbers. Noticing that a bike is blue or that a lemon tastes sour is a qualitative observation. All right, let's go back and find those important words. So I know observing is one of the words. And I want to remember that it means using one or more of your senses to gather information. I'm also going to remember that it might mean using tools, because sometimes we forget that we can use those tools to help us make observations. Now, two other keywords are qualitative observations, and I want to remember that that deals with numbers or amounts. And the other word is qualitative observation. Those deal with descriptions that cannot be expressed in numbers. So those color words are descriptive words. So let's take a look at some of the questions that are off here on their sides. Let's start with this one. We need to make one quantitative observation and one qualitative. So I'm going to write the word quantitative, and that's going to be a number. It's going to be a number-based observation. So let's look at our picture. What's a number-based observation we can make? Yeah, so there might be one chimp. I noticed right away that he's holding one large rock. So I'm going to write holding one large rock. Okay, what about a qualitative observation? So remember, this one doesn't use any numbers. Yeah, so he looks like he's going to use that big rock to make, is like a tool maybe to smash. So I'm going to write, he's using the rock as a tool. And I'll leave it at that. Oops. All right. Now, over here at the target, it asked, in the graphic organizer, ask a what, how, or why question and based on the text under observing. As you read, write an answer to your question. So right now, we're only going to ask the question. We'll come back and answer the question after we've learned a little bit more about our reading. So what is a question that we could ask about observing that we can come back and look at later? All right, I'm going to ask, what type of observations do scientists make? Now, do we know the answer to this one already? Yeah, we do. We know that they make two different types of observations. Do you remember what those are? Yeah, quantitative and qualitative observations. Perfect. Let's keep learning some more. Inferring. So let's number our paragraphs on this page, and I only see the one. One day, Jane watched as a chimp peered into a tree hollow. The chimp picked up a handful of leaves and chewed on them. Then it took the leaves out of its mouth and pushed them into the hollow. When the chimp pulled the leaves out, Jane saw the gleam of water. The chimp then put the wet leaves back in its mouth. Jane reasoned that there was water in the tree. Jane made 3 observations. She saw the chimp pick up dry leaves, put them in the hollow, and then pull them out wet. But Jane was not observing when she reasoned that there was water inside the tree. She was inferring. When you explain or interpret the things you observe, you are inferring or making an inference. Inferring is not guessing. Inferences are based on reasoning from what you already know. They could be based on assumptions you make about your observations. See what inferences you can make about the chimps in Figure 2. But before we do that, let's mark our text. I know right away that I see the word inferring, and I want to remember that. So we remember that that's when you explain or interpret the things you observe. And I also want to remember, and it's really important, so I'm going to highlight it, inferring is not guesses. They're based on reasoning from what you already know. So I think that's really important to remember. We're not guessing. We're using what we already know to make a statement. So let's practice some inferring. So we're going to write what we infer about the chimps in the termite mound. So first we're going to observe. We're going to write 2 observations about the chimps on the left. So what could be one observation? Yeah, so one, I noticed that the chimp is holding a stem. What else can I notice from the picture? Yeah, the stem is in the hole, or the chimp is sticking the stem in the hole. All right, so now that we have our observations, what are some inferences we can make? What can we tell about what's happening in the picture based off our observations? Yeah, the first one my first inference might be that the chimp is using the stem as a tool. What's another one? Why do we think he's using the stem as a tool? Yeah, maybe there's something in the hole he wants. That. Perfect. Nice work. All right, I'm going to go through and number my paragraphs. Predicting. Jane's understanding of chimp behavior grew over time. Sometimes she could predict what a chimp would do next. Predicting means making a statement or a claim about what will happen in the future based on past evidence. So I want to remember the word predicting, and that it means making a statement or a claim about what will happen in the future based on things that have happened before. So a prediction happens before you make any observations. By observing, Jane learned that when a chimp was frightened or angry, its hair stood on end. This response was sometimes followed by threatening gestures such as charging, throwing rocks, and shaking trees. Therefore, when Jane saw a chimp with its hair on end, she was able to predict that there was danger. Predictions and inferences are closely related. While inferences are attempts to explain what is happening or has happened, predictions are statements or claims about what will happen. If you see a broken egg on the floor by a table, you might infer that the egg has rolled off the table. If, however, you see an egg rolling towards the edge of the table, you can predict that it's about to create a mess. So in paragraph 3, I want to remember that predictions and inferences are closely related. But I want to remember that inferences are attempts to explain what is happening or what has happened. And I want to remember that predictions are statements or claims about what will happen. So there is a difference. So looking at the picture of that angry chimp in figure 3, I want you to make a prediction. Write a prediction about what the angry chimp might do next. What might the angry chimp do next? If you need some help, look in paragraph 2, because Jane made some predictions about what might happen when the chimp gets angry. Yeah, the chimp might do things like charge. They might do things like throw rocks. Or they might shake a tree. All right, let's take a look at our do the math box. Like all animals, chimps prefer to eat certain foods when they are available. In the graph, use the information on the table to create a bar graph. So let's start by doing that. So let's start by marking how much of each, or what percentage of each is part of a chimp's diet. And I'm going to use my highlighter tool just to color in the box. So we know that fruit is at 52%. So I know that 50 falls between 40 and 60, so I'm going to go at about the halfway mark, roughly. We know that seeds are at 30%, so I'm going to take a look, and I know that 30 is between 20 and 40, so I'm going to go about halfway. Leaves are only at 12%, and I know that 12 is between 0 and 20, so I'm going to go, just about the halfway mark. And other foods is only 6%. That's really small, so I'm just going to color in just a tiny little bit. Next, we need to label the x-axis and the y-axis on the graph. So our x-axis is here. So what are we showing on the bottom part of the graph? Yeah, we're showing the food types that chimps eat. So I'm going to write just the word food type. Now the y-axis is over on the left-hand side with the numbers. What is that one showing? That's showing the percentage of food type. So I'm going to type percentage of food type. There we go. And finally, we need to write a title for our graph. So what is our graph showing us? Right, it's showing us a chimp diet. So I'm going to write chimp diet. All right, let's move on to number 3. Did chimps feed more on seeds or leaves during May? So what did they eat more of? Right, they fed more on seeds. So I'm going to write in a full sentence, they fed more on seeds than leaves. Okay, and now we're going to make some inferences. What might chimps eat more of if fruits are not available in June? So what might they eat more of if fruits are not available in June? Yeah, they might eat more. Oops. They might eat more of what? Yeah, they might eat more foods that aren't fruits. Like, what else do they eat? Yeah, like seeds or leaves. We'll leave it at that. Awesome. Now on page 8, and I'm going to go through and number my paragraphs again. Start up at the top. Classifying. What did chimps do all day? To find out, Jane's research team followed the chimps through the forest. They took detailed field notes about the chimps' behaviors. Figure 4 shows some notes about Jomeo, an adult male chimp. Suppose Jane had wanted to know how much time Jomeo spent feeding or resting that morning. She could have found out by classifying Jomeo's actions. Classifying is the grouping together of items that are alike in some way. Jane could have grouped together all the information about Jomeo's feeding habits or his resting behavior. So in paragraph 2, I want to remember the word classifying, and then it means grouping together of items that are alike in some way. Paragraph 3, evaluating. Suppose Jane had found that Jomeo spent most of his time resting. What would this observation have told her about chimp behavior? Before Jane could have reached a conclusion, she would have needed to evaluate her observations. Evaluating involves comparing observations and data to reach a conclusion about them. For example, Jane would have needed to compare all of Jomeo's behavior with those of other chimps to reach a conclusion. She would also need to evaluate the resulting behavior data of Jomeo and the other chimps. So I'm going to remember the word evaluating here in paragraph 3. Remember that it involves comparing observations and data to reach a conclusion. And I want to remember that before we can reach a conclusion, we have to evaluate our observations. So we can't come up with a conclusion until we've taken a look at what we've observed. So down in figure 4, it says classifying. By classifying the information related to chimps resting, climbing, or feeding, a scientist can better understand chimp behavior. So we're going to use the chart to classify the details from the field notes. So let's read through the field notes first. 6:45 a.m. Jomeo rests in his nest. He lies on his back. 6:50. Jomeo leaves his nest, climbs the tree, and feeds on visapore, fruits and leaves. 7:16. He wanders along about 175 meters from his nest feeding on bondiagged fruits. 8:08. Jomeo stops feeding, rests in a large tree, feeds on visapore fruits again. 8:35. He travels 50 meters further and rests by a lake. So, how can we classify some of his resting behavior? What does he do when he rests? So let's go through and highlight anything that says when he's resting. So at 6:45, he's resting. And then at 8:08, he's going to rest in a large tree. So what can we write about Jomeo's resting behavior? What does he do? Yeah, so the first thing I remember is Jomeo sometimes lies on his back when he rests. And what else do we know about his resting? What else does he like to do when he rests? Yeah, he rests in some big trees. Okay, now let's take a look at some of his change in locations, his movements. Yep, so at 7:16 he wanders about 175 meters. Yep, and then at 8:35 he travels 50 meters further. So what can we write about Jomeo changing his location? So if we look, this was only over like an hour and a half. So I might write that Jomeo likes to move often. And how far did he move? So 50 meters plus 175 meters gives me 225 meters. And he did that all in the morning. All right. We're now on page 9. So I'm going to number my paragraph, and there's only one on this page. Making models. How far do chimps travel? Where do they go? Sometimes Jane's research team followed a particular chimp for many days at a time. To show the chimp's movement, they might have made a model like the one shown in figure 5. The model shows Jomeo's movement and behaviors during one day. Making models involves creating representations of complex objects or processes. Some models can be touched, such as a map. Others are in the form of mathematical equations or computer programs. Models help people study things that can't be observed directly. By using models, Jane and her team shared information that would otherwise be difficult to explain. So I know I want to remember the word making models, and that it involves creating representations of complex objects or processes. I also want to remember that models can be touched, such as a map, or that they might be mathematical equations or computer programs. That gives me some ideas of different models that can be made. And then I also think it's important that models help people study things that can't be observed directly. So let's look at figure 5. This model shows Jomeo's movement and behaviors during one day. So we're going to use the map over on our right to answer our questions. So my first question is, how far did Jomeo travel during the day? So we're going to use the key on the side, and it shows us how far 100 meters is. So using that key, about how far did Jomeo travel? Good. So it's not going to be exact. So I'm going to write Jomeo traveled about, and using the key I can figure out that he traveled about 1,400 meters. Using the map, how many times did Jomeo stop to feed? So using the key, I know that the star means that he stopped to feed. So how many stars do I see on the map? Right, he stopped 13 times to feed. And then how many times did Jomeo stop to rest? Now using the key on the side, resting is shown by a circle. He rested 5 times this day. All right, now let's assess our understanding. So number 1A says compare and contrast. How do observations differ from inferences? So how are observations different from inferences? So let's start with, what's an observation? An observation is data gathered from our senses, our 5 senses. What's an inference then? Inferences are explanations made from our observations. Perfect. So I'm going to move this. Oops, no. Okay. And B, do you think this statement is an observation or an inference? The cat is ill. You think it's an observation or an inference? I agree. I think it's an inference. But why? Right. It's a reasoned interpretation of a cat's behavior. All right. So let's go down to the got it at the bottom. I get it. I know that scientists use skills such as what? What were some of those keywords or things that scientists do? They do observing, inferring, predicting, classifying, evaluating, and they make models. Awesome job, Dice. That is the end of lesson 1 from chapter 1. If you still have questions, make sure you bring them to class with you on Monday and we can discuss them together.